All right, we're going to give this a shot. So the question says to find the exact value of the trig function given that sine A is 3/5 and cosine B is 12 over 13. So the first thing we want to do is go here and see that it asked for sine of the angle A minus angle B. And so the first thing we got to do is we got to get a formula sheet, and we are going to write the formula for sine A minus B. So if you remember, that's our roadmap. So our formula sheet says sine A times cosine B minus cosine A times sine B. Well, I'm already given sine A and I'm given cosine B, but what I don't have is these two. And so that's where it comes in that we need to draw our diagrams. And I know it's in quadrant 1, so my triangles will look like this. And this is X, this is Y, and this will be for A, angle A. And then we'll draw another one for angle B because that's a completely separate thing. Also in quadrant 1 tells us that. So make sure you label it so you don't get lost. And what we're actually looking for is the sine of A. This sine, cosine of A, sorry. And then the tangent of A. And then we want the sine of B, cosine of B, and the tangent of B. And the reason we want all those is because we know that if we look at these formulas right here for the sum and difference, we know that those are the values that we're going to have to plug in. So we see them all through here. All right, and to do that, we have to remember that sine of any angle is going to be y over r. Cosine of any angle is going to be x over r. And tangent of any angle is going to be y over x. And so if this is sine of the angle A, this is y, and this is r. So we'll put that here. This will be 5 for r. And the y component, which is vertical, will be 3. And we know because of Pythagorean triples that it's going to be 3, 4, 5. If you're not sure, you can use the Pythagorean theorem. That works too because this is a right triangle. And then here we know that cosine is x over r, so the r here will be 13, and the horizontal or x component will be 12, and this one will be 5. And you can use Pythagorean theorem, a squared plus b squared equals c squared, or you can just remember that 5, 12, 13 is another Pythagorean triple. That'll work too. So now going back to this information, we found our missing pieces, and we can write all of the ratios. So sine of A is 3/5. Cosine is x over r, so that's 4/5, and that'll make tangent 3 over 4. And then for sine of B, that's going to be y over r, y component. Here, vertical is 5 over 13. Cosine is given as 12 of 13, and so tangent is 5 over 12. Okay, so now we have everything we need, and guess what? We can just go plug the values in because we found them all. So sine A is 3/5 times cosine of B. Be careful, you're jumping back and forth. So cosine of A is 4/5 times sine of B is 5 over 13. And then we're just going to plug all that into our calculator. So that's going to be, get rid of that, 3/5 times 12 over 13 minus 4/5 times 5 over 13. And it's going to give us 16 over 65, and our key says that's right. And we know it's right anyway. So there we go. All right. So from there, we do the exact same thing, except for we need another roadmap to know what we need. So we're looking for the cosine of A plus B. We're going to get our handy formula sheet here and just copy the actual formula down. So that's going to be cosine A times cosine B minus sine A times sine and B. And oh, lucky us, we've already got all of our values here, so we can just come down and plug them in. And this will be your final answer. Okay, tangent is exactly the same way. This is tangent of A plus B. So we're just going to take our formula and we're going to plug this right on in here so we know exactly what to put in our calculator. Tangent A minus tangent B, 1 plus tangent A times tangent B. Again, we went ahead and did our diligence at the beginning, and so we've got these values, and they just go straight in the formula. Right, so that's number 5, 6, and 7. And I'll make another video for 8 and 9 for law of sines and cosines.